So today we're going to look at a situation as our hero Neo flies to save Trinity as she falls from a skyscraper.
Today we're going to find out if it's safer for her to hit the ground or for Neo to catch her flying at full speed. To begin with, we did extensive research on the situation and the Matrix movie. So to begin with, we had the mass of Neo, which was 75 kilograms, the velocity of Neo, which was 993 meters per second, the mass of Trinity, which was 55 kilograms, the waist of Trinity, which was 0.4 meters, the depth of Trinity, which was 0.2 meters, the height of the building, which was 91.44 meters, or 30 floors, and the height that the collision happened was 2 meters above the ground.
We know Trinity fell from the 30th story. We also know her mass and the acceleration of gravity, so from this we can calculate the gravitational potential energy of Trinity.
Alright, so we're going to start off first by calculating gravitational potential energy. We have the mass of Trinity, we have the gravity constant of Earth, and we have the height displacement. Using these, we just plug it into the equation and we get potential energy. Since we have potential energy, we can now plug it into the kinetic energy formula, just because it is a conservation of gravitational and kinetic energy. Using the formula 12 mv squared, we can find the maximum velocity that Trinity reaches just before she hits the ground. The next step is to find the acceleration of Trinity just as she's hitting the ground till she comes to a stop. But first, before we do that, we need to find time, which we will use a rearranged velocity equation. Once we find time, we can just simply plug that into the equation and we have acceleration. The next step is trying to find the force at which Trinity hit the ground with. We just need to plug our given and calculated values to find the force. The next step after that is to calculate impulse with F delta t. We just found the force and we had the time from steps before, so it is an easy fix. We can find the impulse, which is the change in momentum.
Now we can find the potential energy of Trinity. So we have her mass, the gravitational energy, and the height. So the height is the total height of the building minus 2 meters because she's actually caught 2 meters above the ground. So we plug all those in, find EG, and as we know, EG is equal to EK. Now that we have Trinity's kinetic energy, we can use EK equals 1/2 mv squared to find out her velocity. Plug in all the numbers and we get 42 meters per second.
Given the velocity and the width of Trinity's body, we can calculate the time it takes for Neo to accelerate her to his speed, which is 993 meters per second. Given that, we can find her acceleration, and that is 98,004 meters per second squared. Given Trinity's mass and acceleration, we can calculate the amount of force that Neo applies to her body as she accelerates to his speed. Given the velocity and mass of each Neo and Trinity, we can use the momentum formula m1v1 plus m2v2 is equal to m1 prime v1 prime plus m2 prime v2 prime, and we can use that formula to solve for their combined velocity after this inelastic collision occurs.
Human bones can withstand 3,600 newtons of force. By catching her at full speed, Neo applies over 5 million newtons of force, which is 10 times the amount of force she would experience if she hit the ground.
Not only would catching Trinity do more damage, she would probably be split right in half.